Polyamides are condensation polymers in which an amide functional group links together monomer units. Now you'll see the amide group drawn in different ways. It doesn't matter if the hydrogen off of the nitrogen and the carbonyl are on the same side or different sides. And you'll recall that an amide functional group is formed by a reaction between an amine and a carboxyl. So if we have a look at an example where we have a diamine monomer, so we can see here we've got an amine group on each end, so it's a diamine. And a dicarboxylic acid. Being a condensation reaction, we're going to get our small molecule being formed, which is water formed by H2O. So if we have a look here, we're losing a hydrogen from our amine group and a hydroxyl from our carboxyl group. So once we've got our monomers lined up, we can just identify the atoms that are going to form our H2O and remove them. So now we can see that that nitrogen is going to bond to that carbon, carbon to that nitrogen, nitrogen to that carbon. So we can now redraw our chain without those H2O groups. Now within the chain you need to be able to identify your amide group. So keep in mind that your amide group is where you've got a nitrogen bonded to a hydrogen, which is then bonded to your carbon double bonded to the oxygen. So we've got an amide group here, here, and here. Now you're also going to need to be able to identify a repeating unit. So the way I recommend you do that is find one of your amide links and you split that down the middle. Then follow along your chain until you notice that the sequence starts to repeat itself. So you can see that is there. Now this was an example of a polyamide being formed by a diamine and a dicarboxylic acid. It could also, a polyamide could also be formed from a monomer unit which has both an amine functional group and a carboxyl functional group. So that would be an aminocarboxylic acid. Let's have a look at that. So just using the same process we had a look at above, we have got our carboxyl groups lined up with our amine groups, and we're just going to identify the H2O units that come out as water and remove them. Next, we're going to redraw the structure with our new bonds formed between those carbons and nitrogens. Okay, so we can see within our section of polymer chain, we've got a couple of amide links here. We also need to be able to identify the repeating unit. So if we split one of those amide links and follow along the chain until we see the sequence start to repeat itself again, we've identified our repeating unit.